Okay, I got the dual rotor motor generator running on a 12 volt battery, about 12.1 volts going in. Here's the draw, 0.26 amps. I can change it to up to 400 milliamps down to 150 milliamps by adjusting the timing of the Hall effect, but we're just going to go with this because it's going, if this was a, let's see, 15, 30, 1,540, you can see that. It's going the speed of like if you had a 50 hertz rotaverter motor going on it. So it's going about 1,500 RPM, between 15 and 16 right now. So there's some pretty cool stuff here. Here's the cap I was filling, 800 UF, 810 UF cap. And I have a voltmeter on it. You see that? I guess so. This is, I gotta press this, so it's only at 1 volt in it now. It's in DC volts, 200. Now, watch the volts go up. I'm going to connect a single very fast diode here from the drain of the MOSFET to the positive of the cap, and the negative of the cap shares a common ground with everything. So this is flyback recovery, back EMF, you could almost call it if you feel like it. Back EMF, flyback recovery. And watch how quickly this goes up, and note that the draw doesn't do much. Okay, 1. When I hook this here, it's going to fill up. 1, 2, 3, go. Look where it's at already. Draw actually went, yeah, draw went up a little bit. So there's almost 50 volts in this cap right now. Actually, I am sorry. This is the generator coils going through a, this is the generator coils. This is the generator coils filling this cap with a single diode. .46 volts. Okay. So that's not so bad for the generator coils. Now, remember the motor coils are on this side. Generator coils are inside these white PVC tubes. There's a lot more winds. This is 22 gauge. And I'm pulsing with a 12 volt battery the motor coils on this side. There's 8 of them in series. So now I'm going to do what I thought I was doing. I'm going to do the back EMF recoil flyback. And I'm going to put it into the same cap. So you just saw the generator coils going into this cap with a single diode. Now, let's look at Here's the drain right here, going to the drain of the MOSFET, like the middle pin. It goes into this diode, comes out and goes to the positive of this cap, actually 3 caps together. And then the ground, this gray wire, goes to ground. As soon as I hook up ground, it's going to fill up this cap. And it fills about as fast as the generator coils did. So there's 2 power supplies output. Okay, again, okay, this time we're filling it with a flyback from the drain of the MOSFET, okay? And here's the draw. Here's the voltage that's going to be in the cap. Okay, 1, 2, 3, connect. The draw did go up over there. I have a way of avoiding that. I've done a few videos, but I'm not going to. You're going to have 2 switches. You have one switch that connects the flyback. A little bit delayed to the motor coil pulse, but don't worry about that for now. Okay, let's see this again. You know, I can let this go and it's going to be up to 100 volts pretty soon. This is going to be a pretty big blast at 58. Okay, so there's 2 power sources. The generator coils were not being tapped out, but the flyback was. Now, I was fooling around with this earlier, and instead of running the motor coils and drawing 0.26 amps, you can run the generator coils, which have higher impedance, a lot more winds. Use those as motor coils. So I'm going to show you that right now. And this is pretty interesting. Okay, so just a minute. Okay, now I'm running the generator coils as motor coils. They're being pulsed. I'm doing nothing with the motor coils. They're just free now. Whoa. See that? They touched. I shorted out the motor coils. And that was some lens killing the rotation. Anyways, so look at the draw now. 20 milliamps. And it's 12 volts, so it's drawing next to nothing. And I'm going to take the flyback out into these caps now. And the draw is going to go up over here to about 0.05, I believe, while it's filling. And here's the voltage in the cap over here. Okay, 1, 2, 3, go. So that's something. 33 volts in the cap. Do it again. So that's interesting how little that draws. Let's fill the motor coils. I mean the former motor coils. Let's see what that does. I don't know what's going to happen here. Okay, so now we have the low impedance motor coils working as generator coils, and we have the high impedance generator coils working as motor coils. So did I say that right? We have the low impedance motor coils working as generator coils now, and I'm going to take out power with a single diode into a cap. The high impedance X generator coils are now motor coils. So let's see what happens here. It might kill it, lug it. It's such low power. I don't know. Here we go. Not bad. Not much goes into the cap though. So I guess there's not much current to make much back EMF flyback. Let's try it again. Yeah, not much. Okay, but sure drawing a little, very little power. Here, hold on a sec again. I'm going back to run the motor coils now, the real motor coils, designed to be motor coils. Here we go. You can see it's drawn, how many amps it's drawing. Remember, it's 12 volts, 12.1 input. I'm not taking anything out. This is of the flyback. Now what I'd like to do is see if I can get it up to 1800. That's the speed that this thing goes, 1725 or so. Okay, now just by adjusting the timing of the Hall effect. Right there, I think as fast as I can get it. Oops. I don't think I'm going to be able to get it up to 1800. Look at that. There's a sweet spot. 180, 190 milliamps. Almost 1400. Okay. Here again, I have a voltmeter hooked to this cap here, right here. Let's take out some flyback. This is flyback coming up. The ground, common ground on the ground of the cap, and the diode shoots into the positive from the drain of the MOSFET. So here we go. Drain of the MOSFETs right here. 1, 2, oops. Drain of the MOSFETs right here. 1, 2, 3, go. Wow, that shoots up fast. Do that one more time. Fairly impressive. 190 milliamps, draw, 1, 2, 3, hook it up. Oh shoot, the meter went off. Okay, 1, 2, 3, shoot. I didn't get a good. Here we go. 1, 2, 3, now. Goes up to 22 total. It's up to 58 in a few seconds. Okay, there's that again. Now let's do the generator coils one more time and I'll call it a video. There. Okay, the volts are at like 1 point something. Okay, ready? Here's the draw. Here's the volts in the cap. When I touch this, 1, 2, 3, now. Whoops. There. One, 2, 3, now. I want to show something. Let's say I don't have, I'll fill it up, and I'll just leave a short. No, I don't want to do that. I'll probably blow up a MOSFET. I could just leave the short on this, and the draw will go way up. But I'm not going to do that. Okay, so here we are at 60 volts. Oh, let's check that out. I'm not disconnecting when I short it out. Ready? Watch the draw. Up to 25. We'll do it again. Not disconnecting. Decoupling when I short out the cap. Up. Wow, see that? See how far it went up? That's why when you now watch, I have it decoupled, so when I discharge the cap, you want it decoupled, so watch the draw. It doesn't do a thing now. See that? I'm going to do that one more time. This is important. Okay, filling it up. See that? Get it way up there. Now, I'm going to decouple, disconnect the cap from the generator coils. And now, bang, nothing. It doesn't even flinch. Now, one more time. Generator coils filling up. And now I'm going to leave everything connected. There's no decoupling. Watch the draw. See that? Now if this was very rapid, like once a revolution, you're knocking a discharge into a load, that's what you'd see. It's like 0.33. It's probably going to screw up the MOSFET too. So, anyways, okay. Here it is without being spun by a rotoverter. This is the raw form, how it was supposed to be. So thanks for watching.